Hello geometry students, and welcome to a video on simplifying radicals. So there's a couple different parts of simplifying radicals that we're going to look at. This first video we're going to focus on stuff like this on the bottom of the paper, where you're either looking at perfect squares or you're looking at something that you can simplify, just no fractions, no multiplication, except for a number times a radical, and no addition yet. So there will be more to this, but for now, we're going to start out with the first 12 perfect squares. So I'm going to start you out, and I'm going to pause the video and have you finish them up. Okay, so the first one is 1 squared, which is 1 times 1, or 1. The second one is not 2, but it's 2 squared, or 2 times 2, which is 4. The third one is 3 times 3, and so on. So see if you can fill this out all the way up till you finish the chart. I think it goes up to 12 squared. Okay, so we have all of the first 12 perfect squares. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8, 9, 10 squared, 11 squared is 121, and 12 squared is 144. It's really important that you have these in mind when you're doing the simplifying the way that we're going to do them today. Okay, if you have these 12 numbers in mind, it's really not, one doesn't really matter, but everything else matters. That's going to really make a big difference. Okay, so first of all, we're talking about square roots, so we really need to make a distinction between numbers that are rational and numbers that are irrational, which means not rational. So rational is just based on the word ratio, and this is any number that can be written as a ratio or a fraction. So any number, I will write that down, okay, any number that can be written as a fraction. Okay, that's a rational number. An irrational number, since they're non-rational, probably will be no surprise. These are numbers that cannot be written as fractions. Okay, now this sounds simple enough, but sometimes people do get confused with decimals. And just to clarify, all repeating decimals, so repeating decimals, they're all rational. Okay, and any number that doesn't have a pattern of repeating decimals, like pi, for example, and the square root of 2. I'm going to show you these on a calculator in a second. So pi, square root of 2, also square root of 3. These are all irrational numbers. Square root of 4 is definitely a rational number, because the square root of 4 is 2, and 2 can be written as 2 over 1. So that's rational, but these are not. So let me just kind of show you some of these. We already know, some people, the way they think of pi is a number that goes on forever. And of course it's more than that, but that is a good start at understanding what pi is. So if I hit the key here, it just gives me several versions of pi, several digits of pi, but notice that there's no repeating pattern here. Now if I hit something like a fraction, like 1 divided by 9, watch what happens. See how there's a repeating pattern? Now some numbers have harder to read repeating patterns. Like if I hit, let's see what happens if I hit 2 over 9. That's still really easy. What if we hit 5 over 7? 5 over 7, that's a ratio, that's a fraction. So whatever we get over here, it's still rational. But if you saw it like this, you very well might not realize that it's rational, because you're only getting the very beginning of where it repeats. Now if we had more decimals on this display, we would see the pattern repeat. Okay, so I just adjusted the calculator so you can see a few more decimal places here, and now you can see that 71428. Well, 7143, the calculator rounds the 2, the last digit that it shows, up to 3. And if it continued, if there was another space, this would change to a 2. It would be 28, and there would be a 5, 7, and then another 1, and it would keep on repeating. So even something like this is still a rational number. But something like, again, pi, you're never going to see a pattern like that no matter how many digits you make. And believe me, people have tried looking at millions of digits with computers and looking for a pattern, and there are none. I think even they're up to billions of digits now. All right, let's say you put something like the square root of 2. This is just as irrational, the square root of 2. Now people think pi is the one, that's the special number that never repeats. But all of these radicals have that same property. This will never have a repeating pattern any more than pi will. And that's the nature of all irrational numbers. That when you can never write the whole number out as a decimal. Okay? So it can never, since it never can be written as a decimal, and it goes on forever, it can never be written as a fraction. All right, that's a quick review of rational versus irrational numbers. Now let's talk about what simplest radical form means. So there's two different things that you need to know to have simplest radical form. One of them is you can have no perfect squares inside the radical. Okay, so I'm going to write that down. Okay, so that's kind of like, a fraction's having no factors in the numerator and denominator, like 2/4 is not reduced and you have to completely reduce it. It's the same idea with when you see a radical, that you never, like this is not a reduced radical because you can write it as 2. You don't have to write it as a fraction, you could just write it as 2, but then that is considered simplest radical form. If you leave it as square root of 4, it is not simplest radical form. Okay, the other restriction is you cannot have a radical in the denominator. We're not going to talk about that one today, but I'm still going to write it down because it kind of completes the picture. Okay, so today we're going to focus on this one. This is all that we're going to worry about right now. All right, so we're going to focus on the first rule of simplest radical form today. All right, so let's look at a bunch of these. Now these first ones, the first set of problems, they're all kind of more straightforward because all of these numbers, 49, 121, 64, and 25, all of them are already perfect squares. So we can rewrite the square root as the number that you multiplied by itself to get that number. So the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, etc. All right, so we could just write these. So I'm going to pause it and you can write these in. Okay, square root of 49, 121, and then I'll just those two. Okay, so let me zoom. We'll do 2 at a time. All right, so I'll write these 2 in. Okay. There you go for the first 2. Now let's go on to when there's something in front of it. That's a number that's being multiplied by the square root of 64. So since we know that the square root of 64 is 8, this is really 2 times 8, which altogether 16. Try the next one. Okay, so 5 times the square root of 25 is really just 5 times 5, which is 25. Okay, let's look at the next examples, and this is where it gets more interesting. All right, let's look at these two. Now, these two, neither one of these are perfect squares. We know that the square root of 49 is, but not the square root of 45. We know that 144, that's pretty close, but that's not the same thing. Okay, so we can't use those numbers. What we need to do is we need to think of ways to factor this, break it down into 2 products, where one of the products is a perfect square. So we need to look for factors that are on this list. Okay? So, this is what I call the middle step of the problem. And when you show your work, I do want you to show me this middle step. I don't want you to just skip to the answer. Okay? So, the way we can break this down is the square root of 45 is the same thing as the square root of 2 different things. It's the square root of 9 times the square root of 5. That's because 9 times 5 is 45. Okay? Why did I pick those 2? Because I could have picked 15 times 3. That's not going to help me. This helps me because this one is a perfect square and can be simplified. So this is 3 square root of 5, and that is the answer. Now, had I done something like 15 times 3, 15 times 3 does equal 45, but this won't help me because I can't take the square root of either one of them. Neither one of them is on my list of perfect squares. I'm not really making any progress, so I'm going to say, don't go that direction. You have to look for not just any factors here, but you're looking for factors that have 9, that have one of the perfect squares in them. In this case, it was 9. All right, so it might help, if you write down all the factors here, like how can you get 45? You can get 9 times 5, you can get 15 times 3, and I think that's about it. Okay, don't ever think about decimals. You don't need to do that. All right, let's try the next one. What can we do here? Well, we could do 10 times 15. That's 150. What else could we do? We could do 3 times 50. Now, these are all misses because 10 is not a perfect square, neither is 15. So I didn't make any progress by writing those 2. Same thing here. Neither one of these is perfect squares. But if you know your money, you know the change for 150, you can break it up into quarters, 25s, right? So this is the square root of 25 times how many quarters are there in 150 cents? There's 6 of them, so the square root of 6. Okay. Why does that help us? Because the square root of 5 is 5, and this simplifies to 5 rad 6. That's the middle step. Okay, don't forget to show me your middle step when you do your practice. All right. Now what about this one? Sometimes, you know, numbers like 9 and 25, they're pretty easy. So is 100. But numbers like 36, 49, 64, we're not quite as familiar with all of these numbers right here when we double them or triple them. You're going to have to kind of think about those 4 numbers because sometimes you're going to see double or triple those. So think about that. This is one of those numbers doubled. Which one? 36 times 2. So this is 2 times the square root of 36 times the square root of 2. Okay, do you see that? 36 times 2 equals 72. You want to kind of get a little bit more comfortable with some of those factors that are just like cutting something in half or sometimes cutting something in thirds and thinking if half of it is a perfect square. Okay, this time it is. So this is 2 times 6. 2 times 6 are not square rooted, right? But the 2 still is. So this is 12 on the outside and a rad 2 on the inside. So 12 rad 2. All right. Try the next one. Think about it for a minute. Pause the video. Okay, did you get 81 times 2? 162 is twice as big as 81. Why does that matter? Because 81 is one of our perfect squares, and that's what we need right here. So this is 5 times 9 multiplied together. They're both now outside of the radical, right? This allows me to write it as just 9, and then the rad 2 is in the radical. This is 45. 45 square root of 2. Okay? Let's look at a couple more. They're just the same thing. They're all the same thing. So think about the biggest perfect square that will give you a product of 300. Don't go like, you can go 30 times 10, not going to help you. You can go 20 times, I think 20 goes in, 15. 20 times 15 also happens to be 300, not going to help you. Now you could go 25 because there's this, if this is 300 cents, you could think there's 12 quarters in there, and that will help you, but it's not the best answer because we can do better. That's why. Okay, because this is, whenever you see something that's 300, 500, 700, they're really easy. It's just the square root of 100 times the square root of 3. Just have to realize how easy they are, and then they're really quick. Big numbers like that, even though they're bigger numbers, they're still easy. 10, square root of 100 is 10, times square root of 3, and that is it. Okay. 98, think about it for a second. Okay, so 98 is twice as big as 49, so it's 49 times 2, and so this is, in the end, 7 rad 2. Notice every single problem I'm writing down. Every single problem, I'm writing down a middle step. Here, 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 here. You don't necessarily have to show me that step. One middle step is good enough. Here, middle step, middle step. This one is 64 times 2. Square root of 64, square root of 2. Final answer, 8 rad 2. Okay, I hope you found this video helpful. This is a very important topic, so if you need to watch this more than once, please do so. I want you to get good at this. I want it to be fast because this is going to be something that is recurring quite a bit in geometry.